Okay, as promised, we're going to talk about dividing polynomials now, and this is section 4.3. So one method that we can use to divide polynomials is through long division. Do you guys remember long division from your grade school days? So we're going to take this and divide it by that. So remember that this is called the dividend, this is called the divisor. It's not so important that you remember that, but this is how we're going to set it up. We're going to take this and divide it by this. Notice I have a 0x squared here because this is a degree 4 polynomial. 4, 3, doesn't go 4, 3, 1. It's supposed to go 4, 3, 2, 1. So if there's a spot that we don't have, like a degree that we don't have, we have to put a placeholder there and just call it 0x squared. So that it goes 4, 3, 2, 1, and then the constant. All right. Let's do a real quick refresher on how to do long division. Let's say we were going to do 63 divided by 4. So 63 goes in here, 4 goes right there. I know the 4 goes into 6 one time evenly, right? 1 times 4 is 4, and then I'm going to subtract this from what I started with. So this would be 23. 4 goes into 23 5 times evenly. 5 times 4 is 20. And when you get to the point where this number is less than what you're dividing by, in other words, your divisor, this is the remainder. That's the remainder. So your answer is 15 and the remainder over the divisor. So the answer is 15 and 3/4. Same algorithm is going to be applied, except now it just looks a little more complicated. So I'm going to look at this leading term and think, what would I have to multiply this by to get this first term? Well, I would have to multiply it by 2x squared, right? So, and I have found it doesn't really matter where you put this, just put it on the top there somewhere. I'm going to multiply this whole thing by 2x squared. So 2x squared times x squared is 2x squared. These have to match or you did it wrong. 2x squared times 3x is 6x to the third, and it's positive. 2x squared times 2 is a positive 4x squared. So this is why we put that 0 in there, so that I have something to line this up with. All right, now remember, what did I do with this number? I subtracted it from there, right? So I'm going to subtract all this from this. 2x to the 4th minus 2x to the 4th is 0. I wanted that first term to go away. 3x cubed minus 6x cubed is negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. And then I'm going to bring down one other term. All right. So now I look at this first term in my divisor. What do I have to multiply this by to get that? And the answer would be negative 3x. So I'm going to multiply by negative 3x. Negative 3x times x squared is negative 3x squared, or cubed. Remember, these have to be the same, so I can start eliminating those first terms. Negative 3x times a positive 3x is negative 9x squared. Negative 3x times 2 is a negative 6x. Here's where you're going to make mistakes. Don't forget that you're subtracting all of those things. You're not just adding these. We're subtracting these. So negative 4x squared minus negative 9 is the same as negative 4 plus 9. This would be 5x squared. 5 minus negative 6 is really 5 plus 6, so this would be plus 11x. and I'm going to bring down the last term, which is -1. Okay? So now, what do I have to multiply this by to get this? And the answer is a positive 5. 5 times x squared is 5x squared. 5 times 3x is a positive 15x. 5 times 2 is 10. Don't forget that you're subtracting all this. 5x squared minus 5x squared is 0, thank God, because that's why I did it that way. 11 minus 15 is -4x. -1 minus 10 is -11. I cannot multiply, I'm done. I can't multiply this by anything to get this. So this is my remainder, and this is how you write the answer. You take this part, and then you add the remainder. And the remainder is written like this, 4x minus 11 over the divisor, which is that part right there. Phew. Seems like a lot of work. It is, and there's a lot of chances to make errors. Especially you have to keep telling yourself that you're subtracting these from what you had previously. And that's where your errors are going to happen. But that's how you do that. Also note that if this divided evenly by this, if this were one of the factors of this polynomial function, my remainder would have been 0. I want you to keep reminding yourself that when we're doing this section. So there's got to be a better way of doing division. There is, but it has to meet certain criteria. And the better way is through synthetic division. This goes a little faster. There's less chance for those sign errors. But the only time you can use it is if you're dividing by a binomial in that form. Okay, so when you're dividing by x minus k. In this case, if I'm dividing this polynomial function by x minus 3, then I know that k is 3. All right, so this is how you're going to set it up. These are all of the exponents of my function. So the leading exponent, or the leading coefficient, not exponents, the leading coefficient is -1. The next coefficient is 4. Notice that in this function I'm missing the x term, right? So I have to put a 0 there for a placeholder. And then my constant term is 9. And then you do that, set that up. This is what the k value is. And it's kind of like, when we're doing vertex form and all that, x minus h, x minus k. K is always going to be the opposite of what you think it is because of the way it looks in parentheses. So k is 3. Here's the process. You repeat this and write it down right there. You take this number and you multiply it by that, and you put that answer right there. 3 times -1 is -3. And then you add these. 4 plus -3 is 1. And then you multiply that times that and put that answer right there. 3 times 1 is 3. And then you add these. 0 plus 3 is 3. Okay, wait a minute. -1, -3, 1, 3. Multiply this times this. Put the answer right there. And then you add those. That's my remainder. So the answer, yeah, you're like, geez, Kathy, how do you write the answer? This is my leading coefficient in my answer. And the degree is going to be 1 less than what I started with. So this represents -x squared would be plus 1x plus 3 plus the remainder over my divisor, which remember was x minus 3. Again, I want you to think about this. Because my remainder is not 0, I know that x minus 3 is not a factor of that function. If x minus 3 were a factor of this function, the remainder would be 0. All right, let's look at, well, the remainder theorem, which is what I've been talking about. So we'll just jump. You can go ahead and write that down if you want to. We're going to jump right into an example. So let's say we're taking 5x squared minus 3x plus 2, and I'm going to divide it by x minus 1. Okay, so according to the remainder theorem, when we divide this by this, my remainder is going to be whatever this is evaluated at k. But in this case, remember, k is 1. K is 1. So I'm going to take that function, 5 times 1 squared minus 3 times 1 plus 2 is 5 minus 3 plus 2, which is 2 plus 2 is 4. So the remainder, when I take this function and divide it by that, is 4. And again, I can't stress this enough. Because the remainder is not 0, x minus 1 is not a factor of the polynomial function we started with. And that is it for 4.3.